Hello, welcome back. The title of this lesson is called Unit Circle in Radians. This is one of the most important lessons in all of trigonometry and all of pre-calculus and calculus really, because you use it so much for future work that we do. Now we've already done the unit circle. We know what it is. It's the degree measures all the way around the circle, and then we have the sines and the cosines which come about from the horizontal and the vertical parts of the triangle all the way around the unit circle. It's the projection of that one a unit circle means a distance of 1. It's the projection of that hypotenuse, which has a length of 1, onto the x-axis for the cosine and onto the y-axis for the sine. We've talked about that over and over and over again. That's what the unit circle is. But up until now, we've only worked in degrees, and then in the last couple of lessons, we've introduced the concept of a radian. Remember, every circle has 360 degrees, but if you look at a circle and say that it has 360 degrees, those degrees, 360 is kind of arbitrary. We move over to radians because it's a more natural measurement unit of angles, right? The reason is because if we look at a unit circle of radius 1 and find the circumference of that circle, it's 2 pi r. But if the radius is 1, then it's just 2 pi times 1 or 2 pi radians. That means every circle has 2 pi distance units around its circumference, right? Of if the radius were 1, that is, in terms of a unit circle. So we can think of walking around that circle circumference, the unit circle, and look at the distance around being the angle measure around there. So all the way around is 2 pi radians. We've already talked about that. Now what we want to do is we want to get really comfortable with this unit circle. What I've done is I've moved the degree markings onto the inside. So we have the 30, the 45, the 60, the 90, and then the other markings we've already been using all the way around here, 120, 135, 150, 180. I'm leaving them there. And on the outside in red, these are the projections of the cosine and the sine, the projections of the hypotenuse of this triangle onto the x and y axis. So we've already said, for instance, that a 30-degree angle on the unit circle is right here. So the projection onto the x-axis is its cosine, which is square root of 3 over 2. It's about 0.866. Notice it's less than 1 because we're projecting down here. And the sine is the second number, which is the projection onto the y-axis. That's exactly 1/2. So the cosine is the first number, the sine is the second number. The cosine of pi over 4 is exactly square root of 2 over 2, and the sine is the same number because the projections of the x and the y directions are exactly the same thing. So we've done this whole thing for degrees. Now we need to overlay on top of that radians. So it doesn't change the unit circle, it just changes the markings of the angles. So what we do is we say, well, we start at 0 radians. So in purple is the radian marking, and we start at 0. Now we already said in the previous couple of lessons, and just a second ago actually, that there are 2 pi radians that go all the way around a circle of radius 1, because its circumference is 2 pi times r, which is 1. So 2 pi all the way around a unit circle, so 2 pi radians. So if we go all the way around in the positive direction and get here, we get to the other purple number, which is 2 pi. So you can immediately see that 360 degrees is exactly the same thing as 2 pi radians. There are 2 pi radians in a complete revolution of a circle. That's the fundamental thing. So if 2 pi radians go all the way around, then we already know that going 180 degrees, which goes over here, must be half of 2 pi. And if you do 2 pi divided by 2, because you're cutting it in half, the 2's cancel, and we learned in the last lesson that this is pi radians on this side. This is why 180 degrees is equal to pi radians, and 2 pi radians is equal to 360. We just take the 2 pi and cut it in half, we get pi over here. Now we can take it a step further. If we know that this is pi radians halfway around the circle, if we cut it in half again, we're going to get this angle measure. So if we take pi and cut it in half, what do we get? Pi over 2. That is why the vertical axis, the y-axis up there at the top, is at pi over 2 radians. So you see, you shouldn't be memorizing these things so much as understanding where they come about. It's 2 pi radians all the way around. It's therefore pi radians here, that's half of that. And it's therefore pi over 2 radians, which is half of that up here at 90 degrees. So now we know 3 important points of the unit circle. That 360 degrees is 2 pi, that 180 degrees is pi radians, and that 90 degrees is pi over 2 radians. Now how do we get these numbers here, these important numbers of 30 degrees, 45 degrees, and 60 degrees? We did that math in the last lesson when we learned how to convert degrees to radians. If we take 30 degrees and we go through the conversion factor knowing that pi radians is equal to 180 degrees and multiply through the conversion, we find out that 30 degrees is equal to pi over 6. we do the same math, which we did in the last lesson, we learned that 45 degrees was pi over 4. And if we do the same math on 60 degrees, we learned that pi over 3 radians is equal to 60 degrees. Now here's the kind of the quick way to try to remember this, because all you need to remember is quadrant number 1. The rest of the quadrants is going to come about by counting. I'm going to show you that in just a second. This is the way you figure it out. All right, 45 degrees has a 4 in it. So pi over 4 radians is the only one that has a 4 in the denominator, right? So pi over 4 is equal to 45 degrees. So that's what you should remember. 45 degrees pi over 4. That's how you remember that one. Now 30 degrees, the denominator you might think would be pi over 3, but actually it's the opposite number. So 30 and 60 degrees are the important numbers here. It's the opposite number. So pi over 6 goes with 30 degrees, and pi over 3 goes with 60 degrees. So you have to remember it being backwards. And you should think about that pi over 6 is a smaller number than pi over 3 because the denominator is bigger. So this is actually a smaller number of radians than this right here. So what you need to commit to memory is that pi over 6 is 30 degrees, that pi over 4 is 45 degrees, that pi over 3 is 60 degrees, and that at pi over 2 is 90 degrees. That's all I want you to remember, because every other degree marking that we have, or radian angle measure around the unit circle, we're going to figure out by counting, which I'll show you again in just a second. So before we get to the counting, we've been saying things like sine of 30 is 1/2, sine of 30 is 1/2 to try to help you remember it. Well, now that you know that pi over 6 radians is equal to 30 degrees, you should also then be able to say sine of pi over 6 is 1/2, sine of pi over 6 is 1/2. All right. You can also say cosine of pi over 6 is square root of 3 over 2. Cosine pi over 6 is square root of 3 over 2. Instead of saying sine of 45 is square root of 2 over 2, you could say sine of pi over 4 is square root of 2 over 2. Cosine of pi over 4 is also square root of 2 over 2. And you could do the same thing up here with pi over 3. We know that the cosine of 60 is 1/2, so then we know the cosine of pi over 3 is 1/2. So to memorize these, you do have to juggle some things in your mind. You have to remember the degree, some of their degrees and their cosines and sines. And then you kind of know 30 degrees is pi over 6, and 60 degrees is pi over 3, and 45 degrees is pi over 4. And then the rest of the circle will then fall in place. So what I want to do to teach you the rest of these markings around the unit circle is we're going to learn to count, right? We did this in degrees before, we're going to do it now in radians. So this angle measure all the way up to the 90-degree mark is actually pi over 2 radians from here to here, pi over 2 radians. So I want to count around the unit circle in terms of pi over 2. I want you to think about pi over 2 being an object. It's like a part of a sandwich. We're going to count by parts of a sandwich or parts of a circle. And the chunk that we're counting by here is pi over 2 chunks, which is 90-degree chunks. So here is pi over 2. And if this is pi over 2, then going down here is another pi over 2, because this is another 90-degree segment. So here's pi over 2. This is 2 pi over 2s. This is 3 pi over 2s. And this is 4 pi over 2s. So let's do that one more time. Here's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So what I want to do is walk over here and actually count. We're going to count by pi over 2, which is, as you know, 90-degree chunks. And here's what we're going to say. We're going to say, we'll do it in purple here. We will say that first thing we do is the first increment is just pi over 2. That's what we're counting by. Then it's 2 pi over 2. So it's 2 times pi over 2. But you see what's going on here. Well, let me finish it. 2 pi over 2. Then we have 3 pi over 2s. Then we have 4 pi over 2, right? So we have 1 segment, 2 segment, 3 segments, and 4 segments of this thing called pi over 2. But look what's going on. This fraction cannot be simplified anymore. But this one, you have a 2 on the top and the bottom. So what really this boils down to is this is going to be equal to pi radians, right? Pi radians. It can be simplified, in other words. So if it can be simplified, then what you actually do is you use the simplified version of this. So this ends up being 90 degrees. This is pi radians, which is 180 degrees. 3 pi over 2 cannot be simplified any further, so that's 270 degrees, another 90-degree chunk. And then what do you get here? 4 pi over 2, 4 divided by 2 gives you 2 pi. So this is actually written down as 2 pi radians, which is 360 degrees. Now let's see if these make sense around the unit circle. We said that pi over 2 was 90. 2 pi over 2 is 180. So this is 2 pi over 2, but it reduces to pi. That's why pi is written here and not 2 pi over 2. We don't ever write, in fractions like 5/10 or 50/100. We always write 1/2. We write the simplified version. So if this is pi over 2 and 2 pi over 2, we don't write 2 pi over 2 here. We simplify it to pi radians, which is 180. This is 3 pi over 2. It can't be simplified, so you leave it as 3 pi over 2. And this is 4 pi over 2, which simplifies to 2 pi, which is 360. So that is how you remember these. You don't remember that this is 3 pi over 2. You don't even really need to remember that this is pi. Just count 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. And you can continue. This is 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2. And you would continue going around the unit circle. You could continue counting there. You can also count in the negative direction. These are positive angles. These are negative angles. So you could say this is negative pi over 2, negative 2 pi over 2, which reduces to negative pi. Then you would have negative 3 pi over 2 up here, negative 4 pi over 2, which reduces to negative 2 pi. So going the negative direction gives you the same, is the same exact numbers, but going the other way around the circle. Now the next thing we want to do is start to count by, we want to count by increments of pi over 4s, which is 45 degrees. Remember, it's the only one that has a 4 in the bottom, so it's 45 degrees. So a chunk that we're going to count by now is actually a 45-degree chunk, which is a pi over 4 radian chunk of the circle. So here's how we count. 1 pi over 4, 2 pi over 4s, 3 pi over 4s, 4 pi over 4s, 5 pi over 4s, 6 pi over 4s, 7 pi over 4s, 8 pi over 4s. You're just counting in 45-degree chunks because each chunk of that is pi over 4, and you're just counting around the unit circle. Now let's do the math and see how those shake out as we continue on around. So we said we started off with pi over 4, right? Then we got to 2 pi over 4. But this one can be reduced. What is this going to reduce to? It's going to give you pi over 2, right? Then we have 3 pi over 4. That can't be reduced. Then we have 4 pi over 4. This can be reduced to pi because the 4's cancel. Then we have 5 pi over 4. Then we have 6 pi over 4. This one can't be reduced, but 6 pi over 4, when you divide by 2, you'll get 3 pi over 2. So you divide by 2 and by 2, you get 3 pi over 2. And then you get, so we had 6 pi over 4, then we had 7 pi over 4, then we have 8 pi over 4. Now 8 divided by 4 gives you 2, so you have 2 pi. So you see what's going on? You just count by pi over 4s, but some of the fractions get simplified. That's what's written on the unit circle. So this one is your basic 45-degree position. Pi over 2 is 45 degrees up, which is 90 degrees. Then you have the 3 pi over 4, which is 135. Then you have the 4 pi over 4, which is pi. That gives you 180. Then you have the 5 pi over 4, which gives you the 225. Then you have the 6 pi over 4, which is the 3 pi over 2. That gives you 270. Then you have the 7 pi over 4, which gives you the 315. And then you have the 8 pi over 4, which is 2 pi, which is all the way around the circle, which is 360 degrees. You see, what you're doing is you're writing down you're adding 45 degrees, and we understand that from degrees. We just keep adding 45s around. But whenever you start talking about radian measure, it gets like really confusing. Where is 7 pi over 4 on the unit circle? Tell me, where is 11 pi over 4 in the unit circle? I mean, that's something that's difficult. You could convert to degrees. A lot of students convert to degrees and figure it out, but you don't have to do that. Here's what we're going to do. We're going to mark them all down now. We have pi over 4, 2 pi over 4. Remember, that reduced to pi over 2. Then we have 3 pi over 4. That doesn't reduce, so let's write it down. 3 pi over 4. Then we have 4 pi over 4. That reduces to pi. Then we have 5 pi over 4. I had written that down earlier. Then we have 6 pi over 4, but that reduces to 3 pi over 2. Then we have 7 pi over 4. That goes right here. That doesn't reduce. 7 pi over 4. Then we have 8 pi over 4. 8 divided by 4 is 2. So you get back to 2 pi there, to back around 1 revolution. But you don't have to stop there. You can keep going. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4, 13 pi over 4. So you see, I don't know where 13 pi over 4 is, just like that. I don't know that because I'm not a computer. But I can count and figure out that 13 pi over 4 is here, the same as 5 pi over 4. It's the same position as far as the degree. So if I ask you what is the sine of 13 pi over 4, the first thing to do is to say, okay, well there's 1, 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10, 11, then 12, then 13 pi over 4. It's right here. The sine and the cosine I find using the unit circle methods that we've figured out before. We know the cosine is negative root 2 over 2, and the sine is also negative root 2 over 2. Because at this quadrant, they're both projecting onto the negative x and also the negative y axis. So you see, now we have some more parts of the unit circle now filled in. And notice that when we count by pi over 4s, we overlap with what we had counted by previous, the pi over 2. So now we have a lot of the circle filled in. So now what I want to do next is count by pi over, what do I want to do it? Let's count by pi over 6 chunks. Let's count by pi over 6 chunks. So let's do it verbally, and then we'll go to the board over here. Here's pi over 6. This will be 2 pi over 6 because it's a 30-degree wedge, right? Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. 12 pi over 6 is 2 pi. So we count all the way around. Let's go over here and actually pull it off, and let's count by increments of pi over 6, which is increments of 30 degrees. All right, now I'm going to have to break it up into 2 lines here. So we'll kind of just take our time with it. Here we have pi over 6. Right? The next guy is 2 pi over 6. Then we have 3 pi over 6. Then we have 4, whoops, let me see here, 2 pi over 6. Yeah, I think I'm going to have to do this as I go instead of, I was going to wait till the end. But let's go over here. Let's go back up the truck. Pi over 6, 2 pi over 6. What does this reduce to? You can divide by 2. What are you going to get? Pi over 3. Then you have 3 pi over 6. What are you going to get when you divide by 3? You get pi over 2. You see, I'm able to reduce as I go around. So we're up to pi over 2 now, which is 90 degrees. So 3 pi over 6, we have 4 pi over 6. What does this reduce to? When you divide by 2, you'll get 2. It would be 2 pi over 3. Okay, so that's 4 pi over 6. Then you have 5 pi over 6. This doesn't reduce anymore. Then you have 6 pi over 6, which reduces to, with the 6's canceling, what do you get here? You get pi. So you see, you just count by pi's over 6, but some of these things reduce in terms of where they're at. So what we have is pi over 6, then 2 pi over 6, which was pi over 3. Pi over 6, 2 pi over 6 gives us pi over 3. That's what we already know from before. Then we have 3 pi over 6, which gives us pi over 2. So pi over 6, 2 pi over 6, 3 pi over 6, that gives us the pi over 2. We don't have to write anything new. 4 pi over 6 is 2 pi over 3. So pi over 6, 2 pi over 6, 3 pi over 6, this is 4 pi over 6. And 4 pi over 6 reduces to 2 pi over 3. Then this is 5 pi over 6. So 5 pi over 6. So again, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 reduces to this. 5 pi over 6 doesn't reduce. 6 pi over 6 gives us pi. So just to bring it home, I will write them down underneath. This is going to be 30 degrees here. And then this is going to be 60 degrees. Then this guy is 90 degrees. Then this guy is, let me just double check, 120 degrees. And then this guy is 150 degrees. And this guy is 180 degrees. So these are how you get to the degree the degree equivalency. So if you say, what is 5 pi over 6 equivalent to in degrees? I mean, I can think about it. I can go calculate it. I know how to calculate degrees to radians and radians to degrees, but also I could just do the unit circle. If I want 5 pi over 6, I just start pi over 6. That's 30 degrees up. Then 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. I know that 6 pi over 6 is going to be 180, so I know that 5 pi over 6 has to be 30 degrees less because I'm counting in chunks of 30 degrees, pi over 6. So then I don't really have to calculate it. I don't have to remember it either. I just count around and say, oh, that's got to be 150. All right, but you've got to draw a picture, obviously. Now let's continue going. We got to 6 pi over 6 right here. So we want to continue. We want to go next to 7 pi over 6. This doesn't really reduce to anything. Then we get to 8 pi over 6. 8 pi over 6. When you divide by 2, you'll get a 4 pi over 3. Divide top and bottom by 2. That's the reduced fraction, so we're going to write that one in blue. So we have 7 pi over 6, 8 pi over 6. Here we have 9 pi over 6. And we can divide top and bottom by 3. So this would be 3 pi over 2. And 9 pi over 6, now we have 10 pi over 6. 10 pi over 6 we can divide by 2. So it'll be 5 pi over 3. Divide top and bottom by 2, and that's what we get there, 5 pi over 3. Then that's 10 pi over 6. Now we have 11 pi over 6's. That doesn't really reduce. And then we have finally 12 pi over 6. And that, because 12 divided by 6 gives you 2, you have 2 pi right here. So let's go mark these around the unit circle. The next one up was 7 pi over 6. So this is 6 pi over 6. 7 pi over 6 is here. 7 pi over 6. Then we had 8 pi over 6, but 8 pi over 6 reduced actually to 4 pi over 3. 4 pi over 3. 8 pi over 6 was this. Then we had 9 pi over 6, which was 3 pi over 2. 9 pi over 6, we already have 3 pi over 2 written there, so we don't have to do anything there. 10 pi over 6 was 5 pi over 3. So this is 9 pi over 6, then it has 10 pi over 6, which was 5 pi over 3. All right, and then we had 11 pi over 6, so the next 30-degree segment is 11 pi over 6. And then finally we had 12 pi over 6, which comes down to pi over, or 2 pi. And now you can see in purple, we have the entire unit circle covered. We didn't even count by 60-degree segments yet. We'll do that in a second. You'll find out that everything's already covered. So let's go all the way around in terms of pi over 6 30-degree chunks. Pi over 6, 2 pi over 6 reduces to this. 3 pi over 6 reduces to this. 4 pi over 6 reduces to this. 5 pi over 6 is this. 6 pi over 6 reduces to this. 7 pi over 6, 8 pi over 6 goes to this. 9 pi over 6 goes to this. 10 pi over 6 goes to this. 11 pi over 6 goes to this. 12 pi over 6 goes to this. So again, instead of trying to memorize this table, if I ask you, where is 11 pi over 6? What is the sign of 11 pi over 6? Or where is 11 pi over 6 on the unit circle? What quadrant is it? I don't need to remember that. I don't need to convert it to degrees to figure it out. I just count by pi over 6's. Pi over 6, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 6 is right here. I know it's in quadrant 4, and I know it's 30 degrees shy of a full circle because I'm counting in chunks of 30 degrees. So its sine and cosine are going to be the same numbers as sine and cosine of 30, but I have to put the correct signs on there, just like we have done in the past. So we've counted by 90s, we've counted by 30s, we've counted by 45s. The only thing we haven't counted by is 60s. So let's just do that real quick, and you'll see that everything is already written down in the circle that we need. Let's count by chunks of pi over 3. That's 60 degrees. Here's pi over 3. This would be 2 pi over 3. It's already there. This would be 3 pi over 3, but 3 pi over 3 is pi, so it's already there. This would be 4 pi over 3, here it is. This would be 5 pi over 3, here it is. This would be 6 pi over 3. 6 over 3 is 2, so it's already there. So counting by 60s is already, when you count by 30s, you already complete the circle, then you count by 60s, everything's already there. So the bottom line is, if your thing you're counting by has a 6 on the bottom, you're counting in 30-degree chunks. You go all the way around, simplify the fraction, that's where you're going to be. When you're counting by something that has a 4 in the bottom, you're looking at 45-degree chunks. So that's going to be somewhere on a 45-degree chunk. If you have a 3 on the bottom, you're somewhere on the 60-degree chunks. I mean, look at this. This is a kind of a counting by 60-degree chunks. This, again, is reduced to pi, but it's another 60-degree chunk. But basically, the clue to where you are in the unit circle is the denominator of the fraction. If it has a 2 on the bottom, you're going to be somewhere up here at 90 degrees or 270. If you have a 4 on the bottom, you're going to be on somewhere on a 45-degree diagonal, somewhere on this thing. If you have a 6 on the bottom, really, if you see that you have a 6 on the bottom, you know that you're at a 30-degree angle, reference angle from the x-axis. But really the safest thing to make sure where you're at, if you're trying to figure out, for instance, 5 pi over 3, you need to count by chunks to see what segment you're in. So pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Oh, I'm in quadrant over here. And because I was counting in terms of pi over 3s, which is 60-degree chunks, then I know the reference angle is 60 degrees, or pi over 3, same thing. And so then when I want to find the sine and cosine of this, I can just look here, or I can say, oh, well, I need the sine or the cosine of 60 degrees. And then I can go find that out from knowing what everything is in quadrant 1. So once again, everything boils down, everything comes down to knowing what's going on in quadrant 1. You do not need to know that this is 11 pi over 6. You do not need to know that this is 7 pi over 6, but you do need to know how to count to get there. Okay? I'll close the lesson with one last thing. What if I give you, some students might say, I don't want to know how to count by radians. I'll just calculate, throw it in my calculator. You can do that, but then you'll eventually get hung up on something. What if I give you, a negative angle? Maybe a negative angle is going to confuse things a lot more because you're not counting this way, you're going the other way. What if I say, tell me what quadrant negative 3 pi over 4 is? Negative 3 pi over 4. So you might have to do some gymnastics if you don't actually know how to count. But if I'm telling you it's negative 3 pi over 4 and you're going this direction, here's how you would do it. Here's negative pi over 4, because it's a 45 degrees, negative 2 pi over 4, negative 3 pi over 4. Negative 3 pi over 4 is over here in quadrant 1, 2, 3, quadrant 3. So here again, negative pi over 4, negative 2 pi over 4, negative 3 pi over 4 is exactly the same thing as positive 5 pi over 4, right? So negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4. The 4's cancel, it's going to be negative pi, which is exactly what you would expect it to be since this is positive pi. So you can count negative, you can count positive. Counting in chunks of radians is really, 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 really helpful. All right. Now, back when we first introduced this, we did a giant chart that had sine and cosine and tangent and all of these angles around the unit circle. We then filled around the edges of the unit circle and we filled out that really big chart and it had all the degree measurements. I'm not going to write that chart down again because all I would do is copy the exact chart down, nothing changes, but instead of degrees, I would put all of these radian measurements there. So if you crack open your textbook, there'll probably be a big chart with a bunch of radian markings all the way around throughout the chart telling you what the sine of pi over 4 is, or the sine of 3 pi over 4, or the sine of 4 pi over 4, whatever, going all the way around. I don't think it's worth our time to fill out a giant chart because in reality, all we're going to do is figure out what quadrant we're in, figure out the reference angle, we're going to get the sine and the cosine from quadrant 1 like we always do, and then we're going to apply the negative or the positive sign to it depending on what quadrant we're in. We've already done all of that stuff working in degrees. Now what we need to do in the next lesson is start to take the sine and the cosine of any of these angles in radians. So I will tell you, for instance, what is the sine of 4 pi over 3? What is the sine of 6 pi over 3? What is the sine of 4 pi over 3? Whatever. And what you'll do is you'll have to count around to figure out what quadrant you're in. Then you'll find the reference angle and we'll do everything exactly the same as what we've already done in degrees. So make sure to understand this concept, follow me on to the next lesson, and we will then start to calculate sine, cosine, tangent, and all the other trig functions in radian measure using the unit circle.